Imagine you are a software engineer working for a major telecom company. You make a small addition to the code, then it brings down half the network. This is exactly what happened on January 15th, 1990 at AT&T. Up to that day, technicians upgraded the software to speed up the processing of certain types of messages. Even after being tested thoroughly, one line added to the software was added to 114 switches that controlled the network. That line was a break statement. If we take a look at the pseudocode, that break statement is located at line 10. That break statement introduced a severe problem. It would cause data to be overwritten that was needed later. The problem began in New York City, where the switch had performed a routine self-test that it was noticing that the low limit was drawing near. It was standard procedure for the switch to perform a reset and send a message to the other networks letting them know that this network will not be taking any more calls until further notice. Once the switch reset, the New York switch would send signals that it was backed up with calls while offline. Somewhere else in the country, a switch would pick up the message from New York and update the status to show online. The problem lies here. A second message was sent from New York before the first message was handled, where the second message would have been saved for later processing. However, the break statement caused the information related to being back online to be overwritten by the second message. This then propagated throughout the network because it would send the same message to the backup switch, which would shut down also. When the second switch came back online, it would send the same message to another switch, causing that one to shut down and reset also, ultimately causing a domino effect. On a normal day in 1990, AT&T could route over 115 million telephone calls built on the backbone of those 114 switches throughout the United States. Each switch was able to handle up to 700,000 calls an hour. When a call would arrive, a switch would scan a list of 14 different possible routes to complete the call. It would also pass the telephone number to other networks that checked the alternate routes to determine if the switch at the other end could receive the call. If the destination was busy, the switch would send the caller a busy signal and release the line. A single network computer made a reservation at the destination switch and ordered the destination to pass the call so long as it was good. This happened if the switch was available. This entire process took 4 to 6 seconds. Because of this simple error, AT&T was unable to connect around 50% of the calls placed throughout them. AT&T lost more than $600 million in unconnected calls. It is unknown how much total business was lost by airline reservation systems, hotels, rental car agencies, and other businesses that relied on the network. No matter how much testing can be done, errors can still happen.